This is joint work with Michael Cohen, who is professor at the University of Aizu, in Aizu Wakamatsu in the mountains in eastern Japan, and with Blanca Mancilla, who is my wife. She works at a company called Mental. And I work at a company called Grammatech, which is in Ithaca, where Cornell University is, and I'm still attached to UNSW Australia. All right, so this is the, I can't move around, okay. So this is the problem. It's just a coincidence that there were two separate presentations about parentheses. In this case, it's square brackets as opposed to curly braces.
It's not a coincidence.
Sorry?
This is a coincidence.
What did FDR say? You can be sure in politics that if two things happen coincidentally, it's because it was planned that way. All right. So here we have some horrendous combination of square brackets and open parentheses. And at some point you get lost in the sea of parentheses and brackets, and you don't know how to match things up. So the idea is to match them up by adding additional visual cues. And so we end up with the term Zebrackets, as in zebra brackets. And so obviously you can see here, is there a pointer somewhere?
It's right there on the...
This thing?
Yep, just don't point it in your eye.
You don't point it that way? I was once teaching a class of 700 students, and I had someone point one of those straight in my face for a few minutes, and it took several weeks to recover. So this is 0, 1, 2, 3, the matching 3, the matching 2, open 4, 5, the matching 5, the matching 4. Did I get this wrong? Oh yes, this is the matching 1. So we were at 4 here. We were at 5 here. So now we're at 6, 7, 8, and you get the idea. All right. And so that's the idea. Now they've been greatly. Obviously, this is gobbledygook. You wouldn't want this in a printed text, but just to make it easier to see for the presentation purposes. So, a bit of history. 23 years ago, Michael Cohen presented the first version of this. It was a paper, a pseudo-dynamic contextually adaptive font. And his implementation was mixed porridge, Perl, C, shell script. And I visited at Tokyo in 2013, so 20 years later. Hence the title of the name, A Score of Years. Michael suggested that we revive the work. We did, but continuing to use porridge. At some point, it just became clear that perhaps we should clean it all up. So Blanca and I rewrote the whole thing in Python, and it's a lot more flexible and usable. I was in Aizu in March, and that's when we finished the project. So let's come back to our initial example. So there's a bunch of parameters that are controlling this. So obviously these are meta fonts. So we're not working with PostScript fonts, obviously, because the nice thing of the meta fonts is that everyone has them. They're textual files, so they can be easily edited. So this is computer modern, magnification 4. We started with a CMR of 10. So the rest are parameters. So we're working with 5 slots here. We can have up to 7 slots. Here you can see, I guess, 1, 2, 3, 4. You can imagine there's a 5th, which is never used in this particular example. The origin is 0. That means that the initial opening delimiters counted that from 0. There are 2 options: count from 0 or count from 1. Foreground, that means that the striations are in dark. There's no empty slots behind them. in this case, the indexing is unique. So every pair of delimiters is separately counted. All right. Mixed count is 2, which means that we're mixing the counting of the square brackets and the parentheses. And the direction is top down. In other words, we start, that's position 1, that's position 2, that's position 3, position 4, position 5. Bottom up would be starting from the bottom. All right. So we can look at these one at a time. So if we look at so what we're going to do is we're going to take exactly the same thing. We've reduced the magnification to 2 so we can put multiple ones on the same page. All the other parameters are held constant. And what we're doing here is varying one single parameter. So in this case, we're varying the index. There's 3 possibilities: unique, depth, or breadth. So unique, we saw this in the last example. So each separate pair of delimiters is counted. So 0, 1, 2, 2, 1, 3, 4, 4, 3, 0. Now depth, here what we're trying to do is think of it as a tree. Now we're keeping track of the depth of the parentheses at any given thing. So 0, 1, 2, 2, 1, 1, 2, 2, 1, 0. So that's the one that many of us will be familiar with from various exercises, programming 101 exercises. And breadth, this is less used, but it's still useful. The idea is that for any given level, you're recording which position is it in that specific level. So there's only one set of delimiters at depth 0. At depth 1, well, there's the first pair, and here's the next pair. So, or rather, this is the 0th pair, and there's the first pair. At depth 2, here is the 0th pair, and here is the first pair. So the index is these 3 different parameters. The style, well, there's foreground, which, given the fact that we're working with metafont and at low resolutions, these things sort of disappear. It's the easiest to read, but if we were working with, say, some sort of PostScript font or open type font, then it would be we could get better resolution. Background, you're simply leaving slots out. And hybrid is you mix the foreground and the slots. And so in hybrid, you put in all of the slots. And so it really becomes like the zebra of the Zebrackets name. The encoding, so unary corresponds to base 1 counting. Binary base 2 counting, and demux is a variation on unary, right? So so you're thinking of base 1 count is counting the sticks, so but with the 0 added. So 0, 1, 2, 3. When we're running out, we wrap around. So. Yeah, so so binary, well, that's 0, 1, 2, it's just like I taught my kids to count 1, 2, 3, 4, 5, because they got up to 10, they couldn't go any further. I said, why don't you count binary to get further? Demux, well, it's essentially binary, but only the last one is held. So 0, 1, 2, 3, 4, 5, 6, 7. And there's 8. All right. So demux carries the same information as unary, but it's a lot less cluttered, shall we say. So mixed count, this is where, do you count the brackets and parentheses separately, or do you count them as a single entity? And this really depends on the kinds of actions that you're working on. If you're doing mathematics, mixing may well be appropriate because it's a bit of convention whether you decide to use square brackets and parentheses. I'm not the expert. But if, say, you were working with chemical expressions where there is a clear rule, you alternate between the parentheses and the brackets. To mix them, you'd literally be wasting half of the potential positions. So here we have 0, 0, 1, 1, 2, 2, 3, 3, 4. There's a 4. There's a 4, 5, and so on and so forth. All right. So how you use this is your choice, right? And finally, the origin. Do we start counting from 0, or do we start counting from 1? Oh, and then there's one more, top down and bottom up. So bottom up, you see, they're all mirrored. So here's the 1 position, there's the 2 position, there's the 3 position, and so on and so forth. All right, so how does this work? Well, obviously we need fonts. So the fonts are, they're essentially, we added some, I think it's 2 files that need to be edited to change the shapes of the parentheses and the brackets. And then you have to decide, well, are you producing parentheses? Well, you need the kind, which is either parenthesis or bracket, the style, foreground, hybrid, or background, the number of slots, the size, the family, and the magnification. And here the magnification is powers of root 2. All right. And so in this case, and then you end up with half of your font is open delimiters and the other half is closed delimiters. So how does this work? So this is generated from our system. The user writes a LaTeX file with suffix ZBTeX, it's for Zebrackets. And the user makes annotations of the form, either Zebrackets text, open brace, stuff, close brace, or else begin Zebrackets, end Zebrackets pairs with appropriate parameters. And the parameters are given with the open square bracket, a whole bunch of key value pairs, and then close square brackets. And so these designate regions of text in which the delimiters are transformed with striated glyphs. And you can either do it explicitly, designate, you can actually pull out a font and say, I want this particular symbol, so you can do this completely manually. Or, and in which case then you would have to you'd have to add an extra instruction to make sure that the specific font actually is created. Or else it can be done automatically. Now for the automatic striation, it's a 2-pass algorithm, because the first pass you have to determine the maximum depth or maximum breadth to determine the number of slots that you would need for your for the fonts that will be generated. And once you compute the number of slots, and as I said, there's a maximum of 7, and it wraps around automatically beyond that. So if you get to 128, it becomes 0. And, so you're doing modulo 2 to the number of slots. And the second pass goes through and simply replaces the delimiters in the text with specific glyphs, with a backslash symbol with the appropriate parameters. And all the parameters have default values, and the default values were those that were in bold in the when I was enumerating them. So I think it's foreground, 0 indexing, et cetera, et cetera. Right? So you didn't even get to your 5 minutes.
No, I haven't touched.
So basically, the user adds annotations in the source file. These are interpreted by Python script to generate a LaTeX file. The implementation is slow. For one thing, I'm using Python. Another is I haven't cached any of the font information. And there's huge amounts of redundant error checking. So if were this to be done in a production thing, then there's obvious performance improvements. So they'll probably be done in a couple of hours, but they haven't been done. So I think the proof of concept is successful. the grand vision that's talked about in the last line, it's essentially the idea that, you know, we now have pretty powerful computers. You know, this phone is pretty powerful. Your phones are probably more powerful than mine. Mine's 3 years old now. And so that means that we can do we can generate every glyph on the fly. And we can do this as to an arbitrary level of parameterization for each of these glyphs. So the previous talk gave us an example of determining the exact shape and size of the delimiters. Here's another approach, but this can be used for all sorts of things. And I think also the talk that was given on the first day about, you know, the parenthesization of subordinate clauses and other parts of a sentence. These are all various ways of dynamically generating text. So I think that we can go much, much further. And for that, of course, we need an engine which is much more powerful than the current tech engine. But that's for later. Thank you. Buddies.
Yeah. Well, I have actually a question or a comment, whatever, which is opposite to your third conclusion. My question was, why did you do this in Python? It's relatively easy to do all the calculations and virtual fonts using just tech, and
No, it's not.
Why?
Well, I mean,
you have active parentheses, you go through parentheses, you do this stack calculations, what is your current level. If you want to have two passes, okay, I write it to Ox file, and then I calculate my virtual font. I can do this all in tech.
I don't like tech macros.
Uh-huh.
For me, tech macros is an abomination of a programming language, and I think many people share this idea.
It would be easier for users just to have it text-based.
No, it's not easier for me. Let me tell you, it would not be easy. I mean, for serious performance, I'd write in C++. And I actually decided I don't like Python after this experience.
Dave. One question is, have you considered using gray coding rather than straight binary, so that you only have one tick change per change in coding?
There are many parameters that could be added to this. And so one of them could be color, another could be grade levels, another, so I have thought of it, what to do with this in some sort of production system, I have no idea. This is more of an experiment, sort of playing around sort of thing. I think that, you know, if you were seriously doing typesetting of chemical journals or other things where these kinds of monster expressions appear regularly, then that may well be an interesting way of doing things. The problem with these striations, at least especially when you're working with the metafonts at lower resolutions, is that the striations are hardly visible. And so they don't add that much information visually. It's only when you get to larger sizes that you really see them. Question at the back.
Yeah, this, as I understand what you're saying, is for the output. It seems, I like these little zebra things. It seems like they would be quite handy in my text editor for keeping my curly braces and my square brackets and my parentheses all straight.
Absolutely. In my opinion, a text editor is just another form of a typesetting system. It just happens to be interactive. No, one aspect of the editor is a typesetting system, rather, which is for your screen.
So how do I get these into
I can't answer that right now, but this is a good question. I think in Emacs we could probably figure this out.
It's already there.
Yeah, I mean, apparently, parent is highlighting is standard in every model editor nowadays, right? I mean, including different kinds of parent is Zebrackets and parent
Okay,
content.
all right.
And
So you-
highlighting the backwards,
yeah.
so I mean,
Okay, right, okay. Okay.
Additional questions?
Thank you very much.